Hello everyone. In this session I am going to discuss how to find inverse of matrices. For this we need concept of determinant. So first we see determinant. If A is 2 is to 2 order a square matrix, then determinant of A is written as this, right? Or determinant of A. Delta is also used for determinant. Determinant of a matrix of order 1 is to 1, one row and one column. Suppose this is 1 is to 1 order matrix, so its determinant value is simply this element. Determinant of a matrix of order 2 is to 2, A11 A22 minus A12 A21. This is determinant value of second order square matrix. Determinant of a matrix of order 3 is to 3. Determinant of matrix of order 3 can be determined by expressing it in terms of second order determinants. This is known as expansion of determinant along a row or a column. By using expansion along any row or any column, we can convert determinant of matrix of order 3 is to 3 into 2 is to 2. And how to find determinant of matrix of order 2 is to 2, right? So dear students, for 3 is to 3 order matrix we have 3 rows and 3 columns, so we can take expansion of determinant of 3 is to 3 order matrix along 3 rows and 3 columns. So we have total 6 ways to expand determinant of matrix of order 3 is to 3, right? This is 3 to 3 ordered square matrix A. We are going to apply expansion along first row, second row, along third row, similarly along first column, second column, third column. So we will get same value of determinant for these 6 expansions. So we can use any one to get the value of determinant. First we see the value of determinant by expansion along first row, right? A11 So minus 1 raised to the power 1 plus 1 into this element A11, leaving row and column passing through this element. So we have determinant of order 2 is to 2. So we have reduced its order, and how to find its value we know. Multiply principal diagonal elements minus off diagonal elements, product, right? Product of principal diagonal elements minus product of principal diagonal elements. We are using expansion along first row. So for this second element, plus minus 1 raised to the power 1 plus 2, A12 and leaving column and row passing through this element. So we have this, and this elements of second order determinant A21, A23, A31, A33 plus minus 1 raised to the power 1 plus 3. First row and third column element is represented by A13 into this A13, leaving row and column passing through this element, right? So we have this second order determinant, right? Minus 1 raised to the power 2, it is plus 1 into A11 plus A11, A22, A33 minus A23, A32. This is minus 1 into A12 minus A12, A21, A33 minus A23, A31 plus minus 1 raised to the power 4, it is plus 1 into A13. So plus A13, A21 into A32 minus A22 into A31. So this is the value of determinant. Matrix has no value, but it's a determinant. If matrix has arrangement of numbers, then its determinant value has some value, right? Its determinant has some value, but matrix has no value. It is just like arrangement of anything, object, number. If matrix has numbers, then its determinant has value. And for first order, second order and third order square matrix, we can calculate its determinant value. Similarly, we can get the value of determinant by expansion along second row in the same way. So these are second row elements. Minus 1 raised to the power 2 plus 1, this element A21, and leaving row and column passing through this element. So we have A12, A13, A32, A33. Minus 1 raised to the power, this is element in second row and second column, so it is represented by A22. So minus 1 raised to the power 2 plus 2, this A22, leaving row and column passing through this element. So we have second order determinant after leaving elements lying on this row and this row. So we are having A11, A13, A31, A33. Minus 1 raised to the power 2 plus 3 into this element, right? And leaving elements lying on row and column passing through this element. A11, A12, A31, A32. So this is the value of determinant and both are same. If you check properly, both are same. Similarly, the same determinant value can be obtained by expansion along third row. We can also find the value of determinant by expansion along first column. Like minus 1 raised to the power 1 plus 1 A11, leaving elements lying on this line and this line. So we are getting second order determinant minus 1 raised to the power 2 plus 1, this A21, leaving elements lying on this line and this line passing through this element A12, A13, A32, A33. Right. So for 3:3 order determinant, we have 6 ways for its expansion, right? So in 6 ways we can calculate the value of determinant. We are going to find the area of triangle whose vertices are given. This is a triangle formed by these 3 points x1, y1, x2, y2, x3, y3. Arrangement of coordinates of vertices of triangle in this determinant gives area under this triangle x1, y1, 1, x2, y2, 1, x3, y3, 1. Now friends, move this point to this point. So now the new triangle is this. Its area reduced. Further move this point here. Area further reduced. So value of determinant also reduces. Move this point here. This is triangle and its area is further reduced. If this point is lying on line joining remaining 2 points, so we have collinear points, right? So for 3 collinear points, the determinant value must be 0. It means it is not going to form triangle. So we have 0 value for this determinant having elements from coordinates of 3 collinear points. बात समझ में आया? Minors and cofactors. Minor of an element aij of a determinant is the determinant obtained by deleting its ith row and jth column in which element aij lies. Minor of an element aij is denoted by mij. So minor is also a determinant which is obtained by removing elements lying on line passing through that element for which we are actually calculating minor determinant, right? This is matrix, and dear friends, and its determinant is this: 1 2 3 4 5 6 7 8 9. These elements are written there, right? So we are going to find minor of A11. It is denoted by symbol M11, and it is obtained by leaving elements lying on this line and this line. This is row passing through this element, and this is column passing through this element. So leaving all elements lying on this line and this line, this is called minor of this element A11. So minor is determinant obtained by leaving elements lying on a line passing through that element for which we are calculating minor. Minor of the element A12 is represented by M12, and it is obtained by leaving row and column passing through that element. So A21, A23, A31, A33. Right. Minor of the element A13, A21, A22, A31, A32. Cofactor of any element of a determinant. The minor mij multiplied by -1 raised to the power I plus j is called the cofactor of the element aij. Mij is the minor of element aij of a determinant, right? Aij is ith row and jth column element, right? And how to find its minor we know. Leaving elements passing through this element, right? Removing row on and column passing through this element aij, the resulting determinant is called minor, and minor is multiplied by -1 raised to the power row and column position sum I plus j. So A11 -1 raised to the power 1 plus 1 M11. So this is M11, and it is multiplied by -1 raised to the power 1 plus 1. So this is cofactor of the element A11. Cofactor of element A12 -1 raised to the power 1 plus 2, right, into M12, minor of this element A12, right? So friends, for all elements we have cofactors, right? If elements are replaced by cofactor, the determinant is called determinant of cofactors. And if replace these elements by cofactors. The resulting matrix is called cofactor matrix, and its transpose is adjoint A matrix, adjoint of A, right? So cofactor matrix is important to know inverse of that matrix. सभी एलिमेंट्स के कोफैक्टर्स कैलकुलेट करेंगे और एलिमेंट्स को कोफैक्टर से रिप्लेस कर देंगे, तो जो मैट्रिक्स आएगा दैट इज कॉल्ड कोफैक्टर मैट्रिक्स. टेक इट्स ट्रांसपोज. इन ट्रांसपोज वी इंटरचेंज रो इनटू कॉलम. फर्स्ट रो बिकम्स फर्स्ट कॉलम, सेकेंड रो सेकेंड कॉलम. तो रिजल्टिंग मैट्रिक्स आफ्टर टेकिंग transpose of cofactor matrix is called adjoint A, and we use adjoint matrix to find inverse of matrix. This is 3:3 order a square matrix, right? Its determinant value is obtained by -1 raised to the power 1 plus 1 into this element, leaving elements lying on this line and this line passing through this element. We are getting determinant of order 2:2, right? Plus a12 into -1 raised to the power 1 plus 2, leaving row and column passing through this element. This is second order determinant. -1 raised to the power 1 plus 3 a13, leaving column and row passing through this element. So this is second order determinant. -1 raised to the power 1 plus 1 into this is called minor, and it is multiplied by -1 raised to the power 1 plus 1. So this is cofactor of this element. So a11 into capital A11 plus a12 into capital A12 plus a13 into capital A13. This is cofactor of this element, cofactor of this element, cofactor of this element. A11 capital A11 plus a12 into capital A12 plus a13 into capital A13 is the value of determinant of matrix A. Dear friends, we can find the value of determinant by expansion along second row elements also. A21 into -1 raised to the power determinant obtained by leaving elements lying on line passing through this element, right? So -1 raised to the power 2 plus 1 into second order matrix. This is cofactor of A21. So A21 into cofactor, A22 into cofactor A22, A23 into capital A23 cofactor. So this is also giving the same value of determinant of A. Similarly we can write like this. बात समझ में आया? ऐसे भी A11 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 plus A21 A21 plus A32 31 into A31 element into its cofactor. All elements of a single row or single column multiplied by corresponding cofactor, taking their sum gives the value of determinant. So 3 और वेज हो जाएंगे। इसी तरह जो ना A12 प्लस A22 प्लस A23 A1 हाँ A32 सेकेंड कॉलम के अलॉन्ग एक्सपेंशन करके डिटर्मिनेंट की वैल्यू निकाल रही है A32। दिस गिव्स सेम वैल्यू ऑफ डिटर्मिनेंट A। क्लियर है कि नहीं? इन डिटर्मिनेंट द सम ऑफ प्रोडक्ट ऑफ elements of any row or column with cofactors of corresponding elements of that row or column is equal to the determinant value। बात समझ में आया? सम ऑफ प्रोडक्ट ऑफ एलिमेंट ऑफ एनी रो और कॉलम with the cofactor of corresponding element of that row or column is called determinant, right? But this element and multiplied by cofactor of this element plus this element multiplied by cofactor of this element plus this element multiplied by cofactor of this element gives zero value। A11 into cofactor of A31 plus A12 into cofactor of A32, A13 into cofactor of A33, this will give zero value। बात समझ में आया? In determinant the sum of product of the elements of any row or column with the cofactor of some other row or column is zero। किसी रो के एलिमेंट्स एंड अदर रो के एलिमेंट्स के कोफैक्टर्स का प्रोडक्ट का सम जीरो आता है। बात समझ में आ गया? जैसे ही ये चेंज हुआ A11 A21 तो सभी एलिमेंट्स उस रो का देख लीजिए A12 A22 A13 A23 ये जीरो आएगा। ठीक है। Properties of determinants। The value of determinant does not change when the rows and columns are interchanged, right? This is matrix A and its transpose matrix is obtained by interchanging row into column। First row becomes first column A11 A12 A11 A12 first row becomes first column, second row becomes second column। This is called transpose of A, right? Now find its determinant value A11 A22 minus A11 A12 A21 and here determinant of transpose of matrix A A11 A22 A21 A12 both are same। So determinant of matrix and determinant of transpose of that matrix both are same। Interchanging rows into columns does not change the value of determinant because this is obtained by this operation, interchanging rows into column, and both have same determinant values। If any row or column of matrix A is completely zero, then its determinant value is zero। Take expansion along first row। अगर फर्स्ट रो के सारे एलिमेंट्स जीरो है तो उसी के अलॉन्ग एक्सपेंशन ले लो। तो इन ऑल टर्म्स वी हैव अ जीरो in the place of element 0 so we have zero value। If any two rows or two columns of a determinant are interchanged, the value of determinant is multiplied by -1. If any two rows or columns of determinant are interchanged, the determinant value of resulting determinant is negative of original determinant. This is a matrix and this is its determinant, right? And this is its value. Now we apply this elementary transformation. R1 is replaced by R2 and R2 is replaced by R1. एरो का हेड जो है ना दोनों तरफ है. R1 की जगह पर R2 कर दीजिए और R2 की जगह पर R1 कर दीजिए. इंटरचेंज कर दीजिए फर्स्ट रो एंड सेकेंड रो को, एक दूसरे से रिप्लेस कर दीजिए. तो आफ्टर इंटरचेंजिंग दिस इज डिटर्मिनेंट, ये अनदर डिटर्मिनेंट हो गया. A21 A22 second row and this becomes first row and first row becomes second row by imposing this transformation. So its value is this. Take minus as common to this. This is actually determinant of A and this is another determinant obtained by interchanging either two rows or two columns, right? So resulting determinant after this elementary transformation has negative value of original determinant before this transformation. So interchanging two rows or two columns changes the sign of determinant. If any two rows or two columns of a determinant are identical, the value of determinant is 0. Here first row and second row are identical, so its value must be 0. So this is very simple. Plus 5 plus minus plus plus minus plus minus plus minus, right? Minus 1 raised to the power 1 plus 1 plus minus 1 raised to the power 1 plus 2 first row and second column, so it is coming minus, and minus 1 raised to the power 1 plus 3 first row and third column. So we assign sign like this: plus 5 leaving row and column, 12 minus 0, minus 3 leaving column and row, 20 minus 8, plus 8, 0 minus 3. So this is 0. Dear students, we can easily prove this without calculating its value. If any two rows or two columns of a determinant are identical, the determinant value is 0. Apply for its proof, apply this elementary transformation. Replace, interchange first and second row. So this first row becomes second row and second row becomes first row. So this is a resulting determinant after this elementary transformation, right? And we know due to this transformation its determinant value is negative of original determinant. So this is original determinant, so its value must be minus of this, and this is itself determinant A. This is itself determinant A. So determinant A minus determinant A, take this on this side. So 2 times determinant A is equal to 0. The value of determinant of matrix A comes 0. तो हमने इससे प्रूव भी कर दिया और यहाँ कैलकुलेट करके भी देख लिया. If all elements of the one row or one column of a determinant are multiplied by same number k, the value of determinant is k times the value of given determinant. Here R1 is replaced by k R1. We are going to multiply all first row elements by same number k, right? And now we calculate its determinant value. So k times determinant, original determinant. This is original and this is determinant obtained by applying this elementary transformation. किसी रो के सभी एलिमेंट्स में अगर आपने मल्टीप्लाई कर दिया सेम नंबर के से, तो डिटर्मिनेंट के जो वैल्यू आएंगे, रिजल्टिंग डिटर्मिनेंट के वैल्यू के टाइम्स ओरिजिनल डिटर्मिनेंट. If A be n row square matrix and K be any scalar, right? Dear students, suppose this is A11, A12, A21, A22. Sorry. This is second order square matrix A. So all elements of this matrix is multiplied by this k. This is a scalar multiplication of a matrix. Now take its determinant value. क्या हो जाएगा? k square A11 A22 minus k square. So k square taken as common, A12. So this is the value of original determinant of matrix A, right? And it is multiplied by k square. K square determinant of, right? So if A is n is to n order square matrix, then Ka determinant value of k comes a raised to the power n determinant of A in this analysis, right? If to the elements of a row of a determinant are added m times the corresponding elements of another row or column, the value of determinant thus obtained is equal to the value of original determinant. Dear friends, here we are going to impose this elementary transformation. First row is replaced by first row plus m times second row. फर्स्ट रो एलिमेंट्स में सेकेंड रो एलिमेंट्स के साथ m मल्टीप्लाई करके ऐड करने जा रहे हैं. फर्स्ट रो एलिमेंट्स में ऐड करने जा रहे हैं सेकेंड रो एलिमेंट्स के साथ m का मल्टीप्लिकेशन करके और फर्स्ट रो की जगह पर लिखेंगे. तो दिस इज नॉट गोइंग टू चेंज द वैल्यू ऑफ डिटर्मिनेंट. द रिजल्टिंग डिटर्मिनेंट हैज सेम वैल्यू लाइक ओरिजिनल डिटर्मिनेंट. So after this elementary transformation, a11 plus m times a21, and this is replaced by this a12 plus m times a22. So first row is replaced by first row elements plus m r2. We can separate by using this technique. a11 a21 a12 a22 plus m a21 a21 m a22 a22. Right? Take m which is common in first row element. तो यहाँ से लेके आ सकते हैं हम लोग. फर्स्ट रो एंड सेकेंड रो बोथ आर आइडेंटिकल, इट्स वैल्यू विल बी जीरो. या आप करो ना ऐसे मल्टीप्लाई करके वैल्यू जीरो आ. तो दिस ट्रांसफॉर्मेशन इज नॉट गोइंग टू चेंज द वैल्यू ऑफ डिटर्मिनेंट. डिटर्मिनेंट ऑफ प्रोडक्ट ऑफ मैट्रिक्स ए एंड बी इज इक्वल टू डिटर्मिनेंट ऑफ ए इंटू डिटर्मिनेंट ऑफ बी. यानी ए एंड बी टू मैट्रिसेस है, तो उसके प्रोडक्ट का मल्टीप्लिकेशन करो दोनों मैट्रिसेस का, एंड देन जो रिजल्टिंग मैट्रिक्स आ रहा है आफ्टर मल्टीप्लिकेशन ऑफ दिस टू मैट्रिसेस ए एंड बी, इट्स डिटर्मिनेंट वैल्यू इज सिमिलर टू डिटर्मिनेंट ऑफ ए इंटू डिटर्मिनेंट ऑफ बी. ए और बी का अलग अलग डिटर्मिनेंट निकाल कर उसको मल्टीप्लाई करो, सेम आएगा. इसका हम यूज करके ये वाला जो रिजल्ट ले सकते हैं. डिटर्मिनेंट ऑफ ए रेज टू द पावर n टाइम्स ए का मल्टीप्लिकेशन करना है. ए इंटू ए स्क्वायर इंटू ए क्यूब इंटू ए रेज टू द पावर 4, ए रेज टू द पावर 4 इंटू ए रेज टू द पावर 5 एंड सो ऑन ए रेज टू द पावर n टाइम्स ए का मल्टीप्लिकेशन. तो हम सबको अलग कर सकते हैं कि नहीं, ए इंटू एन टाइम्स. सबको जो है ना डिटर्मिनेंट से बाहर निकाल कर भी मल्टीप्लाई कर सकते हैं, है ना. मतलब कि सबका अलग अलग डिटर्मिनेंट कैलकुलेट करें. कैलकुलेट सेपरेट डिटर्मिनेंट बाय यूजिंग दिस प्रॉपर्टी. ऐसे तो ये है क्या, डिटर्मिनेंट ऑफ ए रेज टू द पावर n. सभी मैट्रिक्स को n मैट्रिक्स, वी हैव n मैट्रिक्स, राइट. तो मल्टीप्लाई दिस ऑल n मैट्रिक्स टुगेदर and find the determinant of resulting matrix. This will give same value if we calculate determinant of matrix A and take its nth power. A into A inverse. It is always unit matrix or identity matrix of same order of A. इस प्रॉपर्टी का यूज करके हम अलग अलग भी डिटर्मिनेंट निकाल कर मल्टीप्लाई करके जो है ना ले सकते हैं, राइट. तो डिटर्मिनेंट ऑफ यूनिट मैट्रिक्स इज ऑलवेज 1 एंड वी कैन सेपरेट डिटर्मिनेंट ऑफ ए एंड डिटर्मिनेंट ऑफ ए इनवर्स. मल्टीप्लाई दिस टू डिटर्मिनेंट्स. So here determinant of A inverse is equal to 1 upon determinant of A. अगर इन्वर्स मैट्रिक्स का डिटर्मिनेंट पूछा जाएगा तो आप इन्वर्स नहीं निकाले, आप क्या करें, उस मैट्रिक्स का ही डिटर्मिनेंट निकाल लीजिए और उसका इन्वर्स कर दीजिए 1 अपॉन द वैल्यू ऑफ डिटर्मिनेंट ऑफ ए. ठीक है. डिटर्मिनेंट ऑफ एनी n इंटू एन मैट्रिक्स whose all principal diagonal are same, say A, and all other remaining elements are same, say B. Dear students, A, B, 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 A, B, 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 A, B, 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 A. All principal diagonal Elements are same, say A, and all of diagonal elements are same, say B. Right? So its determinant value is obtained by using this formula A plus 3B into A minus B raised to the power 3. Remember this for quick calculation of determinant value of such matrix. The determinant of triangular and diagonal matrix is the product of its leading diagonal element or principal diagonal elements. 1 0 0 2 5 0 3 1 2. So this is lower triangular matrix. Triangle with 0 is formed above principal diagonal. This is called lower triangular matrix. Right? अगर ट्रायंगल यहाँ पर बनता 0 0 0 below, so this is called upper triangular matrix. This lower and upper is justified by comparison between row and column position of this 0 forming triangle. This is in first row, second column, first row, second column, first row, third column, second row, third column. So rowth position is less than column position for this all zeros forming triangle above this principal diagonal. So this is called lower triangular matrix. इस वैल्यू से जानी जाती है, ये वाला जो है ना इससे छोटा है. रो की जो पोजिशनल वैल्यू है, इस एलिमेंट की जो रो की वैल्यू जो आ रही है वो कॉलम वैल्यू से कम है. वही अगर यहाँ पर आता सेकेंड रो फर्स्ट कॉलम 2 ग्रेटर देन 1, थर्ड रो फर्स्ट कॉलम 3 ग्रेटर देन 1, थर्ड रो सेकेंड कॉलम 3 ग्रेटर देन 2, अगर यहाँ 0 बनता ऐसे, तो दिस इज ए ट्रायंगल विथ 0 below this principal diagonal. So this is called upper triangular matrix. So for such matrix, the value of determinant is just obtained by taking product of leading diagonal elements or principal diagonal elements. या अगर diagonal matrix है, for diagonal matrix all of diagonal elements are 0. ये सब 0 होता है. These are diagonal elements and these are off diagonal elements. तो केवल मतलब कि ऑफ डायगोनल एलिमेंट सभी 0 हो जाए तो वो डायगोनल मैट्रिक्स कहलाता है. डायगोनल मैट्रिक्स के डिटर्मिनेंट इज ऑब्टेन्ड बाय टेकिंग प्रोडक्ट ऑफ डायगोनल एलिमेंट्स. राइट? अपर, लोअर एंड फॉर डायगोनल मैट्रिक्स डिटर्मिनेंट इज ऑब्टेन्ड बाय जस्ट टेकिंग मल्टीप्लिकेशन ऑफ just taking product of all principal diagonal elements. Now we define adjoint of matrix. Adjoint. Already I have discussed how to find adjoint. Find cofactors of all elements of determinant of a given matrix. किसी मैट्रिक्स के डिटर्मिनेंट के जितने सारे एलिमेंट्स है सबका जो है ना कोफैक्टर निकालिए. राइट? राइट? या जो ना ठीक है कोफैक्टर निकाला. एंड नाउ फॉर्म कोफैक्टर मैट्रिक्स. Take its transpose. The resulting matrix, that is transpose of cofactor matrix, is called adjoint A. So A11 is replaced by its cofactor capital A11, A12, A12, A13, capital A13, like this. So this is called cofactor matrix. And how to find cofactor of element we know. -1 raised to the I plus j into minor of aij. So take its transpose. This is adjoint of A. Remark: for a square matrix of order 2, the adjoint A can also be obtained by interchanging A11 and A22 and by changing sign of A12, A21. For a square matrix of order 2, we can directly find its adjoint by this using this shortcut, interchanging principal diagonal elements. So a11 becomes a22 and a22 becomes a11, and changing the sign of off diagonal elements, a12 becomes minus a12, a21 becomes minus a21. The resulting matrix is called adjoint of A. This is shortcut technique. Proof की जरूरत नहीं है. Dear friends, we are going to obtain biggest conclusion based on adjoint of A. This is matrix of order 3:3, and this is adjoint matrix of this matrix A, replacing elements by cofactors, corresponding cofactors, right? So this is A and this is adjoint A. Now we multiply A and adjoint A. This is A and this is adjoint A, right? Dear friends, this is way to multiply. A11 capital A11 plus A12 capital A12 plus A13 capital A13. This is the value of determinant A. A11, now repeat first same multiplication technique with second column elements of second matrix. A11 into A21, A12 into A22, A13 into A23. We are multiplying elements with, multiplying elements of first row with cofactors of second row, and we are adding this all. This is 0. Already हमने ये देख चुका है. A11 A31 को फैक्टर किसी अदर रो का है, मल्टीप्लाई कर रहे हैं फर्स्ट रो एलिमेंट्स के साथ, तो ये भी 0 आएगा. सिमिलरली रिपीट सेम ऑपरेशन विथ फर्स्ट कॉलम एलिमेंट्स. A21 A11, दिस इज आल्सो 0. इसके साथ करो A21 A21 प्लस A22 A22. यस, दिस विल गिव द वैल्यू ऑफ डिटर्मिनेंट ऑफ ए. अब इसके साथ थर्ड रो के थर्ड कॉलम के साथ रिपीट करते. A21 A31, वी आर मल्टीप्लाइंग एलिमेंट्स विथ को फैक्टर्स एलिमेंट्स ऑफ सेकेंड रो विथ को फैक्टर्स ऑफ थर्ड रो एलिमेंट्स. So this is 0. A31 A11 0, A31 A21 0, A31 A31, A32 A32, A33 A33. This is determinant, right? This is matrix obtained by multiplying A and adjoint A. We are going to draw a big conclusion. ध्यान दीजिएगा. A and adjoint A को मल्टीप्लाई करने के बाद हमें ये मिलता है. दिस इज मैट्रिक्स. तो गाइस, here we have determinant of A 0 into determinant of A 0 into determinant of A. तो सब में जो है ना determinant of A hidden है, and this is a matrix, right? So in case of matrix, if we take this scalar outside of matrix, तो आपका क्या हो जाएगा, सभी में से निकल जाएंगे, 0 में से भी निकलेंगे. 0 इंटू डिटर्मिनेंट ऑफ ए, 0 इंटू डिटर्मिनेंट ऑफ ए, तो ये 1 हो जाएगा, ये 0 हो जाएगा, 0 हो जाएगा, 0 1 0 0 0 1. तो वी आर गेटिंग आइडेंटिटी और यूनिट मैट्रिक्स ऑफ द सेम ऑर्डर ऑफ मैट्रिक्स ए. तो दिस इज कंक्लूजन. ए इंटू adjoint of A gives determinant of A into identity matrix having order of matrix A. Multiply both sides by inverse of A. A inverse A adjoint A. Adjoint A is also matrix. A inverse This is a scalar. So move this after this. A inverse A is unit matrix or identity matrix. This is adjoint A. If identity matrix is multiplied with any matrix, it is not going to change the matrix. So this will give A inverse determinant of A. This is identity matrix. It is also multiplying with adjoint A. It is not altering adjoint A. Dear friends, A inverse is adjoint A upon determinant of A. So for the definition of A inverse, determinant of A is not equal to 0. Otherwise, we can't find inverse of matrix. So inverse of matrix is defined only for non-singular matrix. If determinant of A is equal to 0, so this A is called singular matrix. So this year in 2025, we have question in our GATE examination from singular matrix. If determinant of A comes 0, A is called singular matrix. So for singular matrix, we are not able to define A inverse. A inverse is only defined for non-singular square matrix, right? So this is formula to find inverse of A, inverse of मैट्रिक्स ए। बात समझ में आया? एडजॉइंट कैसे निकालना है? सारे एलिमेंट्स के कोफैक्टर्स निकालिए, कोफैक्टर मैट्रिक्स बनाइए एंड टेक ट्रांसपोज ऑफ कोफैक्टर मैट्रिक्स दैट इज कॉल्ड एडजॉइंट ए डिवाइडेड बाय डिटर्मिनेंट ऑफ ए, दिस इज ए इनवर्स। इनवर्स कैलकुलेट हो जाएगा, राइट? डियर फ्रेंड्स, a into adjoint A already we have seen like this, and its determinant value A into adjoint A, A into adjoint A is this is a matrix and we are going to find its determinant value. So this is replaced by determinant, right? In case of determinant, here all terms have determinant A in its multiplication. So take determinant of A from first row, take determinant of A, सभी में कॉमन है, फ्रॉम सेकेंड रो, थर्ड रो, तो सब ये 1 बन जाएगा, 1 0 0 0 1 0 0 0 1 एंड 3 टाइम्स जो है बाहर निकलेंगे तो डिटर्मिनेंट A रेज़ टू द पावर 3 हो जाएंगे, राइट? एंड वी कैन सेपरेट determinant matrix A and adjoint A. So determinant of matrix A into determinant of adjoint of matrix A into ये क्या दिया, इसका डिटर्मिनेंट क्या हो जाएगा, डिटर्मिनेंट लेंगे, इसका डिटर्मिनेंट 1 हो जाएगा तो केवल यही बचेगा, ये इसको रिड्यूस कर देगा, 2 बन जाएगा। तो एडजॉइंट डिटर्मिनेंट ऑफ एडजॉइंट ऑफ ए इज डिटर्मिनेंट ऑफ ए रेज़ टू द पावर ऑर्डर -1, थर्ड ऑर्डर का था ये स्क्वायर मैट्रिक्स, 3:3 था ना, तो यहाँ पर 2 आएगा। अगर वही nth ऑर्डर का अगर हमारा स्क्वायर मैट्रिक्स है तो उसके एडजॉइंट का डिटर्मिनेंट वैल्यू कुछ नहीं होता है, डिटर्मिनेंट वैल्यू रेज़ टू द पावर n-1। डियर फ्रेंड्स, कैलकुलेशन ऑफ डिटर्मिनेंट is required, a calculation of adjoint A is important to know the inverse of matrix, inverse of a square matrix, and adjoint A finding is time taking process, right? So here we have shortcut to find adjoint directly. here we have matrix A, a square matrix, 3 is to 3 order, minus 1, 1, 2, minus 2, 1, 4, minus 3, minus 2, 3. So this is first column, middle column, and last column. We start with middle and move in this direction. So middle, last, first, and then move in this direction. And again reach to middle. Middle, last, first, middle. Middle, last, first, middle. Clear? So for M, again start with middle column. Right? Middle column. With its middle element. यहाँ M लिखा हुआ है ना, तो मिडल कॉलम में आना है एंड स्टार्ट करना है मिडल एलिमेंट से. तो दिस इज मिडल एलिमेंट एंड मूव लाइक दिस 1 4 और लिखते चलो ऐसे 1 4 माइनस 2 अगेन 1, फिर से मिडल पर ही आ जाना है. हमने ऐसे नोट कर दिया. उसके बाद क्या है लास्ट. इन लास्ट कॉलम अगेन स्टार्ट विथ मिडल एलिमेंट एंड मूव लाइक दिस -2 3 -3 -2 और ऐसे हमने अरेंज कर दिया. उसके बाद क्या है फर्स्ट वी मूव टू फर्स्ट कॉलम एंड स्टार्ट अगेन विथ मिडल एलिमेंट ऑफ दिस फर्स्ट कॉलम एंड मूव लाइक दिस 1 2 -1 1, राइट, एंड देन मूव टू मिडल कॉलम में मिडल एलिमेंट से स्टार्ट करेंगे एंड ऐसे मूव करेंगे 1 4 -2 1 और ऐसा लिख दिया मैंने. हो गया खत्म. we can easily obtain adjoint A by using this shortcut technique. Dear students, ऐसे जो है ना अरेंज करने के बाद क्या करो 1 into 3 minus product of -2 and 4, it is giving 11. 4 into -3 minus 3 into -2 -6, -2 into -2 4 minus -3, it is giving 7. Similarly, -2 into 2 -3 into 1 -7, -1 into 4 -4 into 1, 1 into 4, right, 4 -2, it is 2. 2 into -2 -4 -4 into -1, it is 0. So this gives adjoint of A directly, and its a determinant value is calculated easily, right, -1 this minus this, ऐसे करो this upon its a determinant value inverse of A. This is A and inverse same हमने मैट्रिक्स लिया है. its determinant value is -3 and adjoint is this, already we have find it. So adjoint of A upon determinant A, this is A inverse. If we multiply A and A inverse, we'll get identity matrix of order 3 1 0 0 0 0 0 1 0 0 0 1. Properties of inverse. A into A inverse or A inverse into A, identity matrix of the same order. A square matrix की निकालते हैं inverse. A and B are inverse of each other, then AB BA identity matrix. AB A and B का मल्टीप्लिकेशन करो, इनवर्स लो, या आप जो ना A का इनवर्स लो, B का इनवर्स लो, B इनवर्स इंटू A इनवर्स, ऐसे मल्टीप्लाई कर दो. सेम A B C इनवर्स इंटू B इनवर्स इंटू A इनवर्स. इफ A B and n into n non singular matrix, then inverse of transpose of A or ट्रांसपोज ऑफ इनवर्स मैट्रिक्स ऑफ ए, कोई दिक्कत नहीं है. उसी प्रकार जो है ना ट्रांजुगेट मैट्रिक्स का इनवर्स या इनवर्स लेकर ट्रांजुगेट लो, ट्रांजुगेट ट्रांसपोज कंजुगेट लेकर ट्रांसपोज लेते हैं. कंजुगेट निकालने के लिए जो कॉम्प्लेक्स पार्ट है, जो इमेजनरी पार्ट है, उसको साइन चेंज कर देते हैं. फॉर 2:2 मैट्रिक्स देयर इज अ शॉर्टकट फॉर्मूला फॉर इनवर्स Yes, for 2:2 matrix, we know how to find adjoint. Interchanging principal diagonal elements and changing only the sign of off diagonal elements, we get the value, we get adjoint A directly, and its determinant value is very simple, right? So क्या हो जाएगा, A inverse for 2:2 ऑर्डर स्क्वायर मैट्रिक्स, हम क्या करते हैं, एडजॉइंट ऑफ A divided by determinant of A. Adjoint of A for 2:2 order matrix is directly obtained by shortcut technique, replacing principal diagonal elements A22, यहाँ बन जाएगा A11, changing sign of diagonal elements, right? So this is adjoint A divided by determinant of A11 minus A11 into A22 minus A12 into A21. That's simple, right? Dear friends, in the next live session, we'll see rank determination. And rank determination is important to know solution of system of linear equation. वो बहुत ही इंटरेस्टिंग है. सिस्टम ऑफ लीनियर इक्वेशन के यूनिक सॉल्यूशन होंगे, इनफाइनाइट सॉल्यूशन होंगे, नो सॉल्यूशन होंगे. उसकी इंफॉर्मेशन के लिए रैंक ऑफ मैट्रिक्स डिटर्मिनेशन इज इंपॉर्टेंट, एंड रैंक डिटर्मिनेशन इज मोस्ट इंपॉर्टेंट कंटेंट फ्रॉम लीनियर अलजेब्रा. मैट्रिक्स का सबसे इंपॉर्टेंट गेट के लिए वही है रैंक डिटर्मिनेशन, और उस पर बेस्ड जो है ना लीनियर सिस्टम ऑफ लीनियर इक्वेशंस के सॉल्यूशन के बारे में, वन सॉल्यूशन होगा, इनफाइनाइट सॉल्यूशन होगा या नो सॉल्यूशन होगा, वो बहुत ही इंटरेस्टिंग होता है. वहीं से क्वेश्चन मैक्सिमम आते हैं. फिर जो है ना आइगन वैल्यूज, आइगन वेक्टर, वो इंपॉर्टेंट पार्ट है. अभी तो हम लोग ये पहले भी पढ़ चुके हुए हैं, है ना, 11-12 में ये सब देख चुके होंगे आप लोग. तो ये इतना तक तो था. इसके बाद जो ना रैंक, आइगन वैल्यू, आइगन वेक्टर, ये हमारे लिए कुछ नया आएगा, और यही गेट का इंटरेस्ट है, यही से क्वेश्चन पूछे जाते हैं. तो वी स्टॉप हियर एंड थैंक यू फॉर वाचिंग इस मैट्रिक्स लाइव सेशन.